back, everyone. We're diving into the fascinating world of 3D printing in space today.
Yeah.
You sent us this really interesting article,
Yeah.
and it's called Glasgow Researchers Present a Unique Take on Zero-Gravity 3D Printing. It's from 3D printing industry. And what really caught our eye is this idea that this technology could revolutionize how we build things, not just in space, but here on Earth, too.
It's pretty remarkable. This research really tackles a fundamental challenge when it comes to construction in space, and that is our reliance on, manufacturing here on Earth.
So what makes building things in space so different from what we do here on Earth? Why is it such a challenge?
Well, just think about it for a second. Right now, pretty much everything we use in space, it has to be built here on Earth first.
Right.
And then launched into orbit. And this really limits us. It limits what we can do in terms of the size, the weight, and even just the complexity of what we can send up there.
Yeah, because you have to make sure it can survive the launch.
Exactly.
It's not just about being functional once it gets there.
Rockets are powerful, but they can also be pretty rough.
Oh, yeah.
You can imagine, a $1 billion satellite
Oh, right.
shaking apart during launch.
Yeah, you don't want that.
It's not a good day for anyone.
That's a very vivid image. So basically, we're kind of stuck with building things that are small and sturdy enough to survive that trip to space, and that really limits what we can actually accomplish out there.
I think that's a great way to put it. It's like we're trying to build a house of cards on top of a jackhammer. The current approach, relying solely on Earth-based manufacturing, well, it's expensive, it's restrictive, and it's definitely not ideal for, realizing our ambitions in space.
Right.
And this is where the Glasgow research comes in.
Okay, so let's talk about that. What are the researchers in Glasgow doing differently? What's their solution to this problem?
So researchers at the University of Glasgow's James Watt School of Engineering, they've developed a 3D printing system. But here's the thing. It's specifically designed for low-gravity environments.
Oh, interesting.
And what really sets it apart, what makes their approach unique, is the use of what's called granular feedstock material.
Granular feedstock. I have to admit, I'm not familiar with that term. Is that different from the typical filament used in, standard 3D printers?
Yes, exactly. Think of it as a really, really fine powder instead of those long, continuous strands of plastic that you see in traditional 3D printers. It's a game changer for a couple of reasons. First, those filament-based printers, they often jam in space.
I can imagine that.
The filaments tend to break or get tangled in microgravity.
Yeah.
And it can completely halt the printing process.
So it's like when your printer jams at home, but a million times worse because you can't just open it up and fix it.
Exactly.
Right.
And the second advantage, this granular material, it flows much more consistently in low gravity. So that allows for faster and more reliable printing.
So that makes a lot of sense.
And you know what? They even tested it.
Yeah.
On parabolic flights.
Oh, wow.
Simulating weightlessness.
You mean like on those Vomit Comet flights?
Yes, exactly.
Wow. I can't even imagine trying to, operate a stapler in those conditions. So they put a 3D printer on the Vomit Comet.
Yeah, it's pretty impressive.
That's wild. Okay, so they've proven that it works in zero-G. But what can we actually do with this technology? What's the big picture potential here?
Well, the possibilities are pretty mind-blowing. Think about this. It could enable us to build large, really intricate structures directly in space. Structures that would be impossible to launch from Earth.
Oh, I see.
We're talking about things like massive solar reflectors. Imagine capturing solar energy 2047 and beaming it back to Earth. It could completely revolutionize our energy production.
So we're talking about a clean, constant energy source beamed down from space. This is starting to sound like a science fiction movie.
It might sound futuristic, but it's definitely within the realm of possibility.
Wow.
The article also mentions space-based pharmaceutical research stations. The idea of producing medication in microgravity that could be far more effective than what we can make here on Earth.
Oh, wow.
They even suggest that insulin produced in space could be 9 times more effective for treating diabetes.
9 times.
Yeah, it's incredible.
That would be a game changer for millions of people. It seems like Glasgow is really at the forefront of this research, but are there other groups exploring 3D printing in space? Is this something that's gaining traction in the scientific community?
Absolutely, and the growing interest in this field really speaks volumes about its potential.
Okay.
For instance, Up, it's a company, and Airbus Defence and Space. They partnered last year to develop a metal 3D printer.
Wow, a metal 3D printer.
Yeah.
Okay.
For the International Space Station.
Wow, so a metal 3D printer in space.
Yeah.
What are they using that for? What kind of things are they printing with metal up there?
So this printer was mainly for research and testing,
Oh.
to demonstrate the feasibility of 3D printing metal in microgravity. They printed various metal specimens,
Right.
brought them back to Earth
Oh.
to analyze. But Airbus, they believe that this technology, it could be really essential for future missions to the moon and Mars.
So instead of trying to haul everything we need from Earth, we could potentially use 3D printing to build habitats and other structures using materials found right there on the moon or Mars.
You got it. It's all about what's called in situ resource utilization.
In situ resource utilization.
It's a mouthful.
Yeah.
But it basically means, using resources that are already available wherever you are. It's like living off the land, but in space.
So that makes sense.
Yeah.
It's about being resourceful and using what's available instead of relying on shipments from Earth.
And this shift, it could completely revolutionize space exploration,
Right.
make it more sustainable, more cost-effective, and ultimately more feasible in the long run.
Okay, so we're building houses on Mars with 3D printers.
Yeah.
But you also mentioned this other really interesting area where 3D printing in space is showing promise. Bioprinting.
Yeah.
Is that what I think it is?
You probably got it.
Are we talking about printing organs and tissues?
Exactly. It might sound like science fiction,
Yeah.
but it's already happening.
Wow. So they're already doing that.
Back in 2016, researchers from TechShot, NScript, and Bioficial Organs,
A lot of names.
they tested a 3D bioprinter
Uh-huh.
on a zero-gravity flight.
Hold on. Another experiment on the vomit comet. These researchers are a lot braver than I am. But what did they achieve with this bioprinter in zero gravity?
So in zero gravity, they were able to print cardiac and vascular structures.
Wow.
They used human stem cells
Oh, wow.
and specialized bioinks that are designed specifically for microgravity.
So we're talking about printing actual heart tissue
Yeah.
in space.
Yeah.
That's incredible.
Mm-hmm.
But why do it in zero-G? What's the advantage of doing this kind of bioprinting in space?
Well, microgravity, it offers incredible precision when it comes to bioprinting. Without the pull of gravity, the bioinks in the cells, they can be arranged into far more delicate and complex structures that would be almost impossible to create here on Earth. They were able to create layers thinner than a human hair.
That's mind-blowing. What's the long-term vision for this kind of bioprinting?
Mm-hmm.
Are we talking about printing replacement organs for astronauts on long-duration missions?
Mhm.
Like, imagine having a bioprinter on a spaceship to Mars.
That's definitely one potential application, being able to print a needed organ right there in space instead of, relying on risky and complex transplant procedures. But it goes beyond just space travel.
Oh, I see.
This technology could completely revolutionize healthcare back here on Earth, too.
That's where it gets really interesting, right? We're talking about potentially ending organ donor shortages and creating personalized tissues for regenerative medicine.
Yeah.
It seems like 3D printing in space, is this something that's truly becoming a reality with potentially world-changing applications?
You're absolutely right. And the most exciting thing is, we're really just scratching the surface here. Who knows what other breakthroughs are waiting to be discovered as we continue to explore the possibilities of manufacturing in space.
All right, before we get lost in the vastness of space, I think it's time to bring it back down to Earth a little bit and talk about the broader implications of this technology. Are you ready to dive a little deeper?
Lead the way.
It's amazing how we started talking about building stuff in space, and now we're talking about how these innovations could transform industries right here on Earth. It really is all interconnected.
It's true. Space exploration has a way of pushing the boundaries of technology, and often those advancements find their way back down to Earth and benefit us in ways we might not have initially imagined.
So if we zoom out a little bit, what does all of this mean for the future of manufacturing? Are we going to see factories in orbit producing products and beaming them down to Earth?
Well, orbital factories might be a little further down the line, but I don't think it's entirely out of the realm of possibility. The real paradigm shift here is this idea of moving away from our dependence on traditional supply chains, relying solely on Earth-based resources.
Right.
Imagine a future where we can utilize materials found in space to create what we need out there.
So asteroids become mining outposts, lunar dust gets turned into building materials, and maybe we even tap into Martian ice for fuel and water.
Precisely. It's about using what's already available to us in space rather than trying to haul everything up from Earth. They call it in situ resource utilization. It's a mouthful.
In situ resource utilization.
But it essentially means living off the land, but in this case, the land is space.
Yeah, that makes sense.
This shift could revolutionize space exploration, make it more sustainable, more cost-effective, and ultimately more feasible in the long run.
I have to admit, a part of me still sees this as something straight out of a science fiction movie, but the research that you're describing, these real-world experiments, they're making it clear that this is becoming a reality.
It is. And when you connect this to the bigger picture, the implications for sustainability become even more profound. Mining and manufacturing on Earth can be incredibly resource-intensive. They can have a significant environmental impact. And launching everything we need for space exploration only adds to that burden.
That's a really good point. It sounds like relying solely on Earth isn't a sustainable model for the future of space exploration.
Exactly. By shifting some of that production to space, by utilizing the resources that are already present there, we could potentially lessen our impact on Earth's ecosystems. It's a way to expand our presence in space while also working towards a more sustainable future for our planet.
It's interesting how this reframes the idea of space manufacturing. It's not just about what we can build out there, but how we build it. It's about being mindful of our environmental impact, even as we venture beyond Earth.
You hit the nail on the head. And this shift in thinking also encourages us to rethink conventional design principles. You see, on Earth, we're constantly battling gravity, right? But in space, that limitation disappears.
So we could potentially create structures in space that are lighter, stronger, more complex than anything we could build down here.
Precisely. Imagine the architectural marvels that we could create. Think about the potential for entirely new types of machines and vehicles designed specifically for the space environment.
So giant space telescopes, sprawling space stations, maybe even space-based transportation systems. The possibilities are pretty mind-boggling when you really start to think about it.
The potential is limitless. And it's not just about the structures themselves either. Think about the materials we could use to build them. We're already seeing incredible advancements in creating new alloys and composites specifically designed to withstand the harsh conditions of space.
And I'm guessing those materials could have some pretty amazing applications back here on Earth too, right? I mean, lightweight, super strong materials could revolutionize industries from aerospace to construction to electronics.
Absolutely. There's a natural synergy there. Advancements in material science for space exploration often find their way back to Earth, benefiting a wide range of industries. It's a beautiful cycle of innovation.
So 3D printing in space, it's not just about building things off planet. It's acting as a catalyst for technological advancements that has implications far beyond that initial goal.
That's one of the most exciting aspects of this field. It's driving innovation in materials, science manufacturing processes, and even our understanding of fundamental physics.
It's really shifting my perspective on space exploration in general. It's not just about planting flags and discovering new planets. It's about expanding our capabilities as a species and finding new ways to solve problems, both terrestrial and extraterrestrial.
That's a great way to put it. It's about pushing the boundaries of what's possible and striving to create a future that's more sustainable, more innovative, and perhaps even more inspiring.
Well, I have to say, I am completely fascinated by this topic now. What are some of the next big milestones we should be looking out for in the field of 3D printing in space? What's next on the horizon?
There are several really exciting developments to keep an eye on. One area that holds immense promise is the continued advancement of bioprinting and microgravity. Researchers are working tirelessly to create even more complex tissues and organs, and I think we could see some major breakthroughs in the coming years.
It's incredible to think about the potential for those breakthroughs to lead to life-saving treatments and therapies, not just for future space travelers, but for people here on Earth as well. What else should we be watching for?
Another area to watch closely is the development of autonomous 3D printing systems for space. Imagine robots capable of building structures and habitats on the Moon or Mars with minimal human intervention.
That sounds like something straight out of a science fiction novel. But wait, didn't NASA recently do a test with a robotic 3D printer that built a structure out of simulated lunar regolith?
They did, and that was a significant step forward. These autonomous systems are going to be crucial for enabling long-duration space missions and eventually making human settlements beyond Earth a reality.
Wow, that's incredible. So what about those space-based solar reflectors we talked about earlier? Is there any progress being made toward making that vision a reality?
There's definitely a growing interest in space-based solar power as a clean and sustainable energy source for the future. Several countries and private companies are investing heavily in research and development, and we could potentially see pilot projects launching within the next decade.
I mean, imagine a world where a significant portion of our energy comes from the sun captured in space and beamed down to Earth. It would be a game changer for addressing climate change and ensuring a sustainable energy future.
It's a truly transformative concept, and it really highlights how space technology can be a powerful tool for tackling global challenges.
This whole conversation has been incredibly eye-opening. It feels like we've gone on this amazing journey from the technical details of 3D printing to this grand vision of a more sustainable and technologically advanced future for humanity both on and beyond Earth.
That's what we aim to do with these deep dives. To explore the interconnectedness of ideas, the ripple effects of innovation, and the ways in which seemingly futuristic technologies can have very real and tangible impacts on our lives today.
You've articulated the mission of the deep dive perfectly. But before we get too carried away with all the amazing possibilities, I think it's important to acknowledge that while we've focused on the potential benefits of 3D printing in space, we also need to consider the potential risks and challenges. Like any powerful technology, it has the potential for both good and bad.
You bring up a crucial point. It's essential to approach any technological advancement with a discerning eye, considering not only the possibilities but also the potential downsides.
So let's shift gears for a moment and talk about those challenges. What are some of the environmental considerations that need to be addressed as 3D printing in space becomes more widespread?
That's an important question and one that deserves careful consideration. One of the most pressing concerns is the issue of space debris. As we launch more 3D printers and other equipment into space, the risk of collisions and the creation of more orbital debris increases significantly.
Right, because we're already facing issues with debris from defunct satellites and spent rocket stages. We don't want to make that problem worse.
Exactly. We need to develop responsible practices for managing and mitigating space debris. And that includes investing in technologies for removing existing debris and designing future missions with end-of-life disposal in mind.
It's like any manufacturing process here on Earth, right? We have to consider the entire life cycle of the products we create, including how we dispose of them responsibly. That same principle applies to space-based manufacturing as well.
You make an excellent point. And another concern is the potential for environmental damage on other celestial bodies from mining and processing resources. We need to proceed cautiously and make sure we don't repeat the mistakes we've made here on Earth where we've sometimes exploited resources without fully considering the long-term consequences.
Right. We don't want to just go to Mars or the Moon and start digging things up without thinking about the impact. It has to be a thoughtful approach.
Absolutely. We need to develop a framework for sustainable resource utilization in space, one that prioritizes the preservation of these pristine environments while allowing for responsible scientific exploration and development. It's about finding a balance between reaping the benefits of space exploration and protecting these celestial bodies for future generations.
That makes a lot of sense. It seems like 3D printing in space, it's not just a cool technological advancement. It's ushering in this whole new era of human exploration and development, one that requires us to rethink our assumptions about resource utilization and environmental stewardship.
You've summarized it perfectly. We're at a pivotal moment in human history, and the choices we make today about how we develop and utilize space technology will have profound implications for generations to come.
This has been such a thought-provoking conversation. It really feels like we've only scratched the surface of this topic. Before we move on, is there anything else we should consider when it comes to the potential challenges of 3D printing in space?
Yes, absolutely. We've talked about the environmental considerations, but we should also touch on the economic and political factors that come into play.
Okay, let's dive into that. What are some of the economic and political implications we need to be mindful of as 3D printing in space continues to advance?
Well, first and foremost, we need to acknowledge that space exploration and development requires significant financial investment. Space isn't cheap.
That's true. Funding for space exploration is always a hot topic.
Exactly. So as 3D printing in space becomes more prevalent, it will be crucial to carefully consider the economic viability of various projects. We need to ask ourselves, what are the potential returns on these investments? How will these technologies benefit society as a whole?
So it's about finding that balance between pushing the boundaries of what's possible and making sure that we're making wise investments that will ultimately benefit humanity.
Precisely. And along with the economic considerations, we also need to address the complex political and ethical considerations surrounding space exploration and resource utilization. For instance, who has the right to extract resources from the moon or Mars? Who governs these activities? These are not simple questions, and they're going to require international cooperation and careful consideration as we move forward.
It sounds like we're moving into the realm of space law and international relations.
We are, and it's essential to have these conversations early on as we lay the groundwork for a future that will be increasingly defined by our activities in space. We need to establish clear guidelines and regulations to ensure that space exploration and development are conducted responsibly and ethically.
These are complex and challenging issues, but it's also really encouraging to see that we're having these conversations and grappling with these questions now as we embark on this new chapter in human history.
I agree. It's a time of incredible opportunity and immense responsibility, and I'm optimistic that we can navigate these challenges successfully.
I'm so glad we're having this conversation. It's been incredibly insightful, and I feel like we've only just begun to scratch the surface of this topic.
I agree. There's still so much to learn and explore as we venture further into this new frontier, and that's what makes this field so exciting.
It's not about having all the answers right now. It's about being willing to ask the right questions, to challenge assumptions, and to engage in thoughtful dialogue as we navigate this uncharted territory.
Exactly. It's a journey of continuous learning and discovery, and I, for one, am excited to see where it takes us.
Well, I think we've covered a lot of ground in this part of our deep dive. We've explored the technical aspects of 3D printing in space, the potential benefits and challenges, and the broader economic, political, and environmental implications of this truly transformative technology.
It's been a comprehensive exploration. I think it's safe to say that 3D printing in space is more than just a fascinating technological development. It's a catalyst for a whole new era of human ingenuity and innovation.
You're absolutely right. But before we wrap things up, I think it's essential to address one final and perhaps most crucial aspect of this topic, the human element. What does 3D printing in space mean for us as individuals? What does it mean for our hopes, our dreams, and our place in the cosmos?
That's a perfect segue into the next part of our discussion. Let's explore the human side of 3D printing in space.
It's remarkable how this conversation has evolved. We began with an article about a specific research project at the University of Glasgow, and now we're discussing the future of humanity. It's incredible.
It highlights how powerful ideas can be. A single innovation can ignite countless possibilities and take us down paths we never anticipated.
I think what's so compelling about 3D printing in space is that it's not just about building things, it's about pushing the boundaries of human potential.
It challenges our perception of limitations. On Earth, we're constrained by gravity, by finite resources, by the way, things have always been done. But in space, those constraints start to fade and new possibilities emerge.
It's like being given a blank canvas and a new set of rules. Suddenly, we're free to reimagine what's possible.
Precisely. And that sense of limitless potential is what makes this field so captivating. It's not just about the technical marvels. It's about that human spirit of ingenuity, the drive to explore and push beyond the familiar.
You know, it makes me think of that Carl Sagan quote, "Somewhere, something incredible is waiting to be known." It feels like 3D printing in space is opening the door to a whole universe of incredible things waiting to be discovered.
It is. And those discoveries aren't limited to the scientific realm. This journey of exploration also leads us to a deeper understanding of ourselves, our place in the universe, and our potential as a species.
We started by talking about the nuts and bolts of 3D printing in space, and now we're talking about the future of humanity itself. It's been quite a journey.
And that's the beauty of these deep dives. We follow the threads of an idea wherever they lead, making connections and uncovering hidden layers of complexity along the way.
We took that initial spark of curiosity about 3D printing in space, and it ignited this whole chain reaction of insights and questions. It's been fascinating.
And that's exactly what we hope to inspire in our listeners. That sense of wonder, that thirst for knowledge, a willingness to engage with the big questions that are shaping our world.
So as we wrap up this deep dive, I want to leave you with a final thought-provoking question. Knowing what we know now about the potential of 3D printing in space, what do you think will be the most impactful application of this technology in the next decade?
It's a question that really challenges us to think beyond the immediate, to envision the possibilities that lie just beyond the horizon.
Will it be the construction of those massive solar energy platforms beaming clean power back to Earth? Or maybe the creation of self-sustaining lunar or Martian outposts, Or perhaps something completely unexpected, a breakthrough we haven't even considered yet. What do you think?
Only time will tell. But one thing is for sure. The journey will be filled with groundbreaking discoveries, bold innovations, and ethical considerations that will test our ingenuity and our collective wisdom.
So keep your eyes on the stars, keep asking questions, and never stop exploring. The future is waiting to be built, and with technologies like 3D printing in space, the possibilities are truly limitless.
And who knows, maybe you'll be the one to make that next incredible breakthrough.
That's a wrap for this deep dive into 3D printing in space. Thanks for joining us on this journey of discovery. Until next time, keep exploring.